Good day, everyone, and welcome to the 19th edition of the group exhibit Hydrogen and Fuel Cell here at the HANNOVER MESSE 2013. For those that are not familiar with the public forum, we invite you to come and have a seat. Drinks are on the house. We have soft drinks and coffee, tea. And to join us on a discussion regarding research for hydrogen and technology at DLR, synergy between fuel cell and electrolyzer. Please help me welcome from DLR the head of department Electromechanical Energy Technology, Dr. Andreas Friedrich.
Hello, Marie-Louise.
Thank you for joining us. DLR is a well-established research center, but for those that are maybe not familiar with some of your past work and current work, could you fill us in?
Yes, so DLR is a German aerospace center, and it's of course active in the area of aeronautics, space, but also in the area of energy for a long period of time. And my section, which is located in Stuttgart, has been involved in electrolyzer development, fuel cells, and also recently in batteries since for more than 20 years. So we have extended experience in these technologies, and have also seen some ups and downs over the time, but yeah, so we are,
I think one thing
we are very experienced in this technology.
You've mentioned over 20 years of research, and just to touch on one point though, you did mention aerospace, and I think it's important to mention that we have another public forum presentation coming up this afternoon with one of your colleagues, and they'll go into details into the aerospace research that you conduct at DLR. But your department is mostly on electrolyzer and PEM fuel cell. You've been developing some special coating for bipolar plate. Why don't you give us a bit more information?
Yes, this year we are presenting a special coating that we have developed, because perhaps some of you know that PEM electrolyzers are a very promising technology, because they have a much higher power density compared to the traditional alkaline electrolyzers, which we know very well because our first projects on electrolyzers were coupling alkaline electrolyzers with photovoltaic fields, so using renewable energy for hydrogen production. This was the so-called High Solar project, a very large demonstration project in Germany and Saudi Arabia. And we know alkaline technology very well, but we are focusing now also on PEM technology, because this has a much higher power density, and therefore you need less materials. You can build much more compact, and we think that this will lead to cost reduction and make hydrogen production much more acceptable for the marketplace. And one aspect here for cost reduction is to replace titanium bipolar plates that are used. And you know, titanium is a very nice material because it has a very high corrosion resistance, but it's also quite expensive, and also it's difficult to machine, difficult to introduce into production manufacturing processes. And we are working on stainless steel materials which are coated by a titanium coating, a specific titanium coating which we apply by plasma spraying, and this makes then stainless steels comparable to titanium
bipolar plates.
Bipolar plates makes it comparable in corrosion resistance. Yeah.
So you're not eliminating the titanium per se, but you're reducing the amount you need.
Right, yeah, we are reducing it to just the coating material. Yeah. And
this coating, this new process that you've developed is on display at your booth, which is right behind us here at C66. Yeah. I invite you to have a look, and they have a nice little pamphlet that describe the process. But obviously it's a new process, and with any new things there's challenges. So what are you facing? What's the next challenge with this coating that you've developed?
Yes, so we have tested the coating under realistic conditions, of course. However, we have not tested the full-scale bipolar plates that will be used for large-scale hydrogen production, and not all geometries that you can think of, which are used in electrolyzer technology today. So the next step will be to apply this coating to large area technical systems and just test the durability under real conditions. Yeah.
So what size are we looking at? What size have you covered now, and which size are we trying to apply it to?
So we have covered now, so in the range of 100 square centimeters of size, and we are going to 10 times this
that size. And what's the...
And with, of course, with flow fields integrated into it, so with more complex geometries. Yeah.
And what's the biggest risk then applying this new coating process to a larger plate brings to the table?
Well, it's the usual upscaling issues. So it means that something that works in a small area may have not as good quality in a large-scale area, because in some areas maybe some pinholes may form, which are not present if you coat a smaller area. But we're very confident that we will achieve also that.
So really the challenge at this point is the manufacturing and processing risk. And you just mentioned pinhole. What is the risk of having a pinhole on a bipolar plate?
Oh, if you have one pinhole in the bipolar plate, this will be the area where you will start corrosion processes in the stainless steel plate. And eventually then you will lose materials there, and eventually the coating will fail from this point. Yeah.
But the early on testing you've done has been very positive.
Very positive, yeah. Yeah.
And for those that were not in Hamburg yesterday, there was a big announcement made.
Yes.
Maybe you can tell us about this?
Yes, we are involved in a large demonstration project with PEM electrolysis. This is headed by a large company in Germany, E.ON. And the companies involved are E.ON Gas Storage and E.ON Hanse, who are building up a 1 megawatt PEM electrolyzer, and they plan, or in 3 years' time, the hydrogen produced by this megawatt plant will be integrated, will be fitted into the natural gas pipeline in Hamburg. So we will demonstrate a power-to-gas concept with hydrogen in natural gas in Hamburg, and the partners, as I mentioned, are E.ON, Hydrogenics, which builds the 1 megawatt electrolyzer, are Solvicor, which produces the coatings, DLR is a research partner, and Fraunhofer ISE also is a research partner.
So basically this new project will allow you to take the hydrogen produced by this 1 megawatt electrolyzer and put it directly into the natural gas pipeline. Is that what I understand?
Right, yeah, into a natural gas pipeline with 30 bar pressure. It's a ring pipeline around Hamburg. And so there's some innovations in this project. First of all, the megawatt PEM electrolyzer. Secondly, the feed-in into the ring pipeline in Hamburg.
And DLR will be involved in the research or the reliability part of the project?
So we will be mainly responsible for the durability issues. So of course, such a concept will need to show acceptable durability to become a business case. And we will take that technology that will be applied to the 1 megawatt plant in a smaller scale, so in our case 50 kilowatts, but with a relevant size, so the size of the cells will be the same as the 1 megawatt plant, and investigate degradation on this relevant smaller power plant.
What type of timeline do you have on that research project for durability? And
so what we will do is we will of course look for accelerated aging, because we don't have that much time. And
we want it out now.
So we will have a 3 years time for investigating our research plant, and then we have the large-scale installation, and then of course we will continue with monitoring the durability after that.
Well, two things. First of all, it's a public forum, so anybody in the audience that has a question, you're welcome to do so. Raise your hand and I'll come down with a microphone. One thing that people in the audience may be asking is, how can we put hydrogen directly in a natural gas pipeline. Isn't there a problem with that? Because we're supposed to use natural gas, not hydrogen.
Perhaps I can answer that. So
yeah.
Certifications allow about 2 to 5% of hydrogen already nowadays in the natural gas. It depends a little bit on the usage of the natural gas in this area. So this is what is allowed today. But there are many research projects going on investigating if this is really the higher limit you can accept, or if it's not possible to go much higher than that. And we will see results in the next years about the possibility for feeding in hydrogen into the natural gas. And my opinion, my personal opinion, is we will see that at least for some areas, for some applications, much higher levels are acceptable.
But for this specific project in Hamburg, they will allow you to put up to 1%, I believe,
1% hydrogen
in the pipeline.
Yeah, yeah.
And without wanting to be critical, I've noticed, I've been here since Monday, I've interviewed a lot of people. It seems like everybody's going towards PEM electrolyzer and dropping the alkaline. At DLR, you've done extensive research in the alkaline electrolyzers, and especially to use renewable energy. And everybody seems to tell me that the reason they're moving to PEM electrolyzer is because they seem to be a better fit with renewable energy. Why not keep the alkaline? Isn't it the work you've proven showed that it would work as well?
Sure, we have also projects on the alkaline electrolyzers, so that's we are not focusing on just one technology. Alkaline electrolyzers, they don't have a durability problem, so they run almost forever, at least in our experience. They are very robust. Efficiency can be improved by electrode coatings that we have developed. So alkaline technology is a feasible technology. However, the power density and the gas quality is inferior to polymer electrolyzers. So the polymer electrolyzers are a very interesting option, and it's necessary to develop this option in order to have a realistic evaluation of technologies.
We have a question on the floor.
Thank you. Theo Holtum, Green Hydrogen Consulting. Alkaline electrolyzers may be cheaper. And
at present, yeah.
If you install an electrolyzer on a much greater capacity wind farm, which would be normal, certainly today's electrolyzers are, single megawatt scale, not, hundreds of megawatts like wind farms, then the ability to track the wind going up and down is less important. You can simply switch it on and off, I think, when you have enough wind or not. So you would only be using a small part of your wind capacity to power the electrolyzer. From this point of view, maybe alkaline electrolyzer is not much different in terms of its compatibility with wind.
Are you referring to the dynamic operation or intermittent operation of alkaline electrolyzers?
I mean, if you have a 100 megawatt wind farm and you have a wind forecast and it's 50 megawatts for the next day and you've got a 1 megawatt electrolyzer, you know it can be switched on all the time. There's no need for it to dynamically match the variability of wind in this case.
I think part of the question is you're trying to see, is it really necessary that we develop PEM electrolyzer that will follow the change in power production when we can just have the alkaline electrolyzer stay on at all time because we're producing a lot more than the maximum power generation of the electrolyzer in the alkaline.
So first of all, you would like to have not to shut down renewable power, right? So you would like to use the renewable power you have, even if you don't use the power directly in the grid. Therefore, you would need an adequate storage medium, and for that reason, you could use the modular approach to electrolysers and build up 1 megawatt modules up to the point which is for your application optimal. And then, of course, if you want to have a very efficient system, and you want also to have some dynamic range, because you don't want to lose hydrogen when the gas quality is not good enough. So you would like to have dynamic systems, and this can be actually also performed with alkaline electrolysis. When you when you activate the electrodes, they become much more efficient and also dynamically operable.
Is gas quality important when you inject direct into the gas bed? I mean, alkaline electrolyzers produce 99.99% pure hydrogen.
Of course. Yeah.
I'm sorry to interrupt. We're just running out of time, and we have another interview coming up. But I will invite you to discuss further this point off the stage, and I'm sure Dr. Friedrich will be happy to have you on his booth at C66, which is right behind us. Please help me thank Dr. Friedrich for his time. We really appreciate it.
Yeah. Thank you.